All right, we're back with inequalities, and I have some examples here of some equations using inequalities. And remember that there's only one general rule that we have to be wary of, and that is if we are going to multiply or divide by a negative number. And it's generally related to the variable. If the variable is negative, then we may need to multiply or divide by a negative number. Or not necessarily the variable is negative, or you can think of the number it's being multiplied or divided by is negative. Then we have to flip the sign. And the other reason we would flip the sign is just by swapping the variable and number and making it more readable so we can graph it. So let's look at these examples. Here's my first one. 7 is less than or equal to x plus 6. All right, in this one, what we would do normally, and you can think of it just an equal sign here. I have a plus 6 here. I do the opposite, which is subtract 6 from both sides. So minus 6, minus 6. If I do plus 6 minus 6, it will be 0. X plus 0 is just x. And then here's my inequality, and then 7 minus 6 is 1. So from this, we get 1 is less than or equal to x. And again, to make this more readable for me, I like to make the variable on the left side of the equation. So x and 1, I flipped them. So if I do that, I have to flip this sign in the center. And it becomes from less than or equal to greater than or equal to 1. So x greater than or equal to 1 is my solution. And let's see what this means. So if I say x equals 1, I go back to my original equation of 7 is less than or equal to x plus 6. And I'll say here 1 plus 6 is 7. So 7 is less than or equal to, 7 equals 7. If I say x equals 2, because here it says x is greater than or equal to 1. So it would be 2, 1, 2, 3, 4, 5. Let's say I use the number 2. 2 plus 6 is 8. And so 7 is less than or equal to 8. And if I say 3 here, 3 plus 6 is 9. 7 is less than or equal to 9. So all these numbers greater than 1 and greater than or equal to 1 work. Let's pretend I use the number 0 in this equation. So this is not part of the solution set. 0 is not greater than or equal to 1. If I put 0 here, 0 plus 6 is just 6. So 7 is less than or equal to 6? No, it's not. So that's why it would not be true. All right, and if I graph this, if you look down here, here's the 1. It's a closed circle because of the equal sign. And it's greater than, so I go to the right. The other way to look at these is if you look at the greater than sign, it's going to the right. It's pointing, it's like an arrow going to the right. All right, next example. W minus 10 is greater than negative 8. Now in this one you might think, oh, there's a negative sign, I might have to flip the sign, the inequality around, and no you don't. Let's take a look at how this works. W minus 10 equals negative 8. I'm sorry, greater than negative 8. So here I have a negative 10, I want to add 10 to both sides. I do the inverse operation of minus, it's plus, plus 10, plus 10. And what I get here is negative 10 plus 10 is 0. W plus 0 is just W. So I bring down the W. Negative 8 plus 10 is going to be 2. Remember, you have a negative and a positive, and when you have one of each, you subtract the smaller from the larger. So 10 minus 8 is 2. And then do I have more positives or negatives? I have more positives. There's 10 and there's 8. So I have more positives, so my answer is just 2. W is greater than 2. And that's it. And so I get down here to 2. It's an open circle, and it's to the right. Again, you can look at the arrow. It's going to the right. Now let's look at the next example here. I have negative 1 is greater than y over 3. And I just want to make a note here. If this was negative 1 greater than 3y, we would just divide both sides by 3 to get our y to be by itself. Y over 3, here we're dividing, so the opposite of division is multiplication. And so we're going to multiply both sides by 3. This is easier as an equation to solve than if it was just 3y. So don't let that fool you. Here I'm just going to multiply both sides by 3, and it's a positive 3, so I will not be flipping the sign. So a 3 here, 3 times negative 1, and a 3 here, 3 times y over 3. So now 3 over 3 is going to cancel to 1. 1 times y is just y. Negative 1 times 3 is going to be negative 3. So negative 3 greater than y. And again, I want to, just for readability and easier for me to graph it, I flip those two around. And if I flip those two around, then I flip the sign around. So my answer is going to be y is less than negative 3. And if I graph that right here, it's an open circle, and the 3, it's y less than 3, so 3 is to the left. So I go this way. And again, if you look at the less than, the arrow direction is going this way. So it'll help you with that. My final example is right here. Negative x plus 5 is less than negative 1. Negative x plus 5 is less than negative 1. So again, the first thing I do, I have a plus 5 here. I want to do the inverse. I do minus 5 and minus 5 on both sides. So this becomes 0. Plus 5 minus 5 is 0. And I just bring down the negative x. Negative x less than, and then negative 1 plus negative 5. They're both negative, so I add them. And so it'd be negative 6. So it'd be negative 1 plus negative 5 is negative 6. This is not the rule where two negatives make a positive. Please do not misunderstand that. I'm not multiplying or dividing these numbers. I'm adding them. So negative 1, I already have a negative 1. I'm going to add a negative 5. I'm going to get a bunch more negatives. So it's negative 6. All right, now I have negative x is less than negative 6. Again, I want this to be a positive x. So here I'm going to multiply both sides by negative 1. And when I multiply now by negative 1, I'm going to go ahead and flip the sign around. So negative 1 times negative x is going to be just a positive x. Two negatives multiplied become a positive x. And here I'm going to, the sign's going to be this way now. It's going to be greater than instead of less than. I flip the sign because I'm multiplying both sides by negative 1. So x greater than, and then negative 6 times negative 1 is going to be a positive 6. So x greater than 6. Let's try some numbers here with that. So x greater than 6. If I put, let's say a 7. I put the 7 in here for x. So negative 7 plus 5 is going to be negative 2, and negative 2 is less than negative 1. If I put in an 8 here, because 8 is greater than 6. 8, negative 8 plus 5 is going to be negative 3. Negative 3 is less than negative 1. And if we go backwards, let's say I pick a 5 here for x. This would not be in the solution set. 5 is not greater than 6. So if I put a 5 in here, it should come out false. So if I put negative 5 here, 5, negative 5 plus 5 is 0. 0 is not less than negative 1. All right, so let's take a look at here, x greater than 6. I go to this 6 here, put an open circle because there's no equal sign, and everything to the right of 6. Anyways, hope those examples help you out. Just, try to understand when to switch the sign or the inequality around. And it's always when you multiply or divide by a negative number, like we did in this equation right here. The other time you would flip the inequality around is when you're rewriting the inequality where you're swapping everything, swapping the two around. All right, we'll talk to you some more later.